Welcome, this is Carrie Rhinehart with 5-Minute Math. Today I'm going to be looking at factoring special products. If you're following along in the book, it's from Algebra 2, Unit 1, Lesson 3. So when they say special products, it's these special rules for factoring. The first one, and one that you may have heard of before from Algebra 1, is called difference of two squares, or dots. Difference of two squares. And just like it says, it's a difference, so that means you're going to be subtracting. And there's two squares. Okay, a perfect square is something like 9, 16, 25, x squared. So it's going to be in the form a squared minus b squared. You've got a perfect square minus a perfect square. An example would be x squared minus 4. Because x squared is a perfect square, 4 is a perfect square, and you're subtracting them. The rule for this, when you're factoring a difference of two squares, it's going to factor into two binomials. The first part you get from taking the square root of a squared. Well, the square root of a squared is just a, so that goes here. You're going to get an addition sign in one and a subtraction sign in the other. And then the second part you get from taking the square root of b squared. Well, the square root of b squared is b. So a squared minus b squared factors into a plus b times a minus b. If we do this for the example, we're going to get two binomials. One's going to be plus, one's going to be minus. It doesn't matter if you do the addition first or second, as long as one's addition and one's subtraction. We need to take the square root of x squared, which is x. So x goes in the front of both. And then the square root of 4, which is 2. So 2 goes here. So x squared minus 4 would factor into x plus 2 times x minus 2. And you can check that by distributing it. So x times x is x squared. X times negative 2 is negative 2x. 2 times x is positive 2x. 2 times negative 2 is negative 4. And what you'll notice here is we've got a negative 2x plus 2x, and those cancel out. So we end up with x squared minus 4, which is what we started with to begin with. So we know that this is the correct factorization. All right, one that's very similar to difference of two squares is called sum of two squares. Okay, so the only difference with what it looks like to begin with is that it's a sum. You're adding instead of subtracting. Oops. So we've got sum of two squares. So it's going to be a squared plus b squared. So something like, let's say 4y squared plus 9. 4y squared is a perfect square because both 4 and y squared are perfect squares. And 9 is a perfect square as well. Now, when you factor this, it's a little bit different. It's very similar. They're both, you're going to get two binomials being multiplied. One is addition, one is subtraction. The first part, you get the same way. You take the square root of a squared. Well, the square root of a squared is just a. It goes in the front. And then the second part is very similar. You take the square root of b squared and you get b. But when it's a sum, you have to put an I with the b. So a squared plus b squared factors into a plus bi times a minus bi. Let's do the example here. So I'm going to get two binomials. One's going to be addition, one's going to be subtraction. We need to take the square root of 4y squared. Well, the square root of 4 is 2, and the square root of y squared is y. So we're going to get a 2y in the beginning of both. Now we need to take the square root of 9, which is 3. So we're going to get a 3, but since this is a sum here, we need to put an I with the 3. And then we can check this to see if it works. So 2y times 2y gives me 4y squared. 2y times negative 3 gives me negative 6yi. 3i times 2y gives me positive 6yi. And then 3i times negative 3i gives me negative 9i squared. Now, you'll notice these cancel out. What you should also notice is that we get an I squared, which we need to replace with negative 1. So I'm going to bring down the 4y squared minus 9 times negative 1. We replace the I squared with negative 1. So when I multiply those, I end up with plus 9 here, which is what we started with, so we know that we've done this correctly. This is the correct factorization.